Now we're going to continue our discussion on quadrilaterals by looking at two types of quadrilaterals, the trapezoid and the kite. Now first, the trapezoid. Trapezoid is a quadrilateral that has exactly one pair of parallel sides. Exactly means no more, no less. So this is an example of a trapezoid. I've drawn it here for you, this pink thing. The little arrows indicate, which sides are parallel. Now, those sides that are parallel, those are called the bases. So there's a base, and here's a base down here. And these other sides are called the legs. Okay, so we've got a leg there and a leg there. Okay, now if these legs are of equal length, then you have an isosceles trapezoid. Okay, so not all trapezoids have the same length of legs. This one does, and this is an example of an isosceles trapezoid. Now, think about this for a minute. Think about if, let me move this out of the way a little bit. Let's suppose that you took this trapezoid here, and let's suppose that you folded it this way. Let's suppose you folded it. You went right in the middle and folded it along this yellow here, so that this side over here was on top of this side. You can see what would happen there. It looks like it would be exactly on top of itself, right? In other words, and this is with an isosceles trapezoid. So that being the case, you can start thinking about this. It seems pretty obvious that these angles, this angle right here, would be congruent to that angle. See? This one and this one. And also this angle and this angle. In other words, the base angles are going to be congruent to each other. Okay? So that seems pretty obvious. You can just look at it. Now, that's not a rigorous proof or anything. That's just you looking at it and saying, yeah, there's some symmetry there going on. Now, if you look at this second theorem here, it says if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So they're giving you a condition that's sufficient. If you can show that one pair of base angles are congruent, then you know you've got an isosceles trapezoid. Okay, now let's look at the next one here. A trapezoid is isosceles if and only if its diagonals are congruent. Okay, so look at this. These diagonals, this diagonal here is the same length as this diagonal here. And when that happens, you know you've got yourself an isosceles trapezoid. Okay, now let's just play around with these trapezoids for just a minute. Down here I've got this thing, okay? So it's an isosceles trapezoid, and we want to find the angle P, the angle Q, and the angle R. That's what our task is at this point. Now we already know that angle R, so we already know the measure of angle R is equal to 50 degrees because it's going to be congruent to its base, its corresponding base angle over there. But what about these other two angles? What about P and Q? Well, look at this. Here you've got a parallel line, another parallel line, and it's cut by a transversal. And you have consecutive angles here. This angle is consecutive with this one. See? So we have two consecutive angles here. We have this, we have a pair of consecutive angles. We have this one and this one are consecutive. That means that the sum of those two are 180. Consecutive angles, when you have parallel lines cut by transversal, consecutive angles are complementary. So you know this. You know the measure of angle P is equal to 180 minus 50, which is going to be 130 degrees. So angle P is 130 degrees, and so is angle Q, 130 degrees. Yeah. So that's that's something we can do with that. Or, that's a typical type of question that we might have involving trapezoids. Okay, now I've got a trapezoid here, and I just want to, let's suppose we've got a shape like this, and we want to determine if this is a trapezoid. Now remember, with the trapezoid, we have exactly one pair of parallel sides. Okay, so the candidate here, it looks like, is going to be this one here and this one here. I'm thinking those are parallel. Well, I want to show that they're parallel, and here's how I'm going to do it. I'm going to find the slope. So I'm going to find the slope of this CD. And here I go. I'm going to take the change in the y's. Okay, so this is going to be 7 minus 4 over 4 minus 7. Yeah, 4 minus 7. And that, of course, is going to be negative 1. Okay, so the slope of this CD is negative 1. Now let's look at the slope of BA. Let's see what the slope of BA is. Well, change in y's. So this is going to be 5 over negative 5, which we get a negative 1. Just doing the slope here. So yes, this is a trapezoid. It's a quadrilateral, a pair of parallel sides. Exactly one pair of parallel sides. Now, I'm wondering if it's isosceles. Well, if it's isosceles, then this length here has to be the same as this length here. That's what has to happen. Let's see if that's the case. Let's look at the length of CB. The length of CB is equal to the square root of 4 squared plus 2 squared. And that's going to be 16 plus 4, that's the square root of 20. See, I just took the difference of the x's, 4 minus 0, and got 4. Difference of the y's, 7 minus 5 is 2. Now let's look at the, that was CB. Now let's look at DA. DA. Well, that's going to be the square root of 2 squared. See, 7 minus 5 is 2, plus 4 squared. Ooh, that's also the square root of 20. So it looks like this is indeed an isosceles trapezoid. Okay, now something else we want to look at with these trapezoids, and this is called the mid-segment theorem. Now, here is a trapezoid, and I've made this one an isosceles trapezoid, but that's not a requirement here. I just did that for simplicity. But let's find the midpoint of this, of both sides, or both legs of this isosceles trapezoid. Now you can look at it here. You can see, okay, I bet that's the midpoint right there, and that's the midpoint there. You can just eyeball it, and you get this distance here, okay? Or you get that segment, the mid-segment for this trapezoid. Now, let me remember how we find the midpoint. We take, so for this one here, for this one right here, we're going to take 3 plus 1 over 2 and 5 plus 1 over 2, and we get 4 over 2, well, that's 2, and then we get 6 over 2 is 3, so we've got 1, 2, 1, 2, 3. Yep, there's the midpoint right there. Now we do the same thing over here, and that's the midpoint segment. When we connect the midpoints from the legs, we got the midpoint segment. Now, dig this. Let's calculate the length of AD. Let's see what AD is. Now, we could use the distance formula, but you can just count here. It's 1, 2, 3, 4, 5. See, 1, 2, 3, 4, 5. There's 5 of those. 5 little, that you can just count to see what the length is. Down here you've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's that right there. I'm calling this, where did I get the AD from? Let me do this. Let me say this is A, B, C, D. I guess I was looking up at the theorem, little green box there. But AD is equal to 5. Now let's see what BC is equal to. BC is equal to, let's see, I counted it, but I forgot. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So AD plus BC is equal to, BC is equal to 14. Now, remember what the length of the midpoint segment is here. It's 1, 2, 3, 4, 5, 6, 7. So the midpoint segment, or the mid segment, I should call it, mid segment, is equal to 7. And notice that's half of that 14. And that's what this theorem is saying. It says that, if this is MN here, then MN is 1/2 of AD plus BC. Yeah, that's what that's saying. Okay, so now let's move on to kites. When we talk about a kite, we're talking about a quadrilateral with 2 pairs of consecutive congruent sides. So here I've drawn one. It kind of looks like a kite, right? So notice we have consecutive sides. We have this side here and this side, congruent. This side and this side. So we have 2 pairs of consecutive congruent sides. Now, just some things to notice about this kite. Notice if I were to, drop a line down here like this, you can see immediately that we have 2 triangles, and in fact, these triangles, this triangle over here and this triangle here, those are congruent. And you can see that to be the case because you have side, side, side. Notice, this side and this side are congruent, this side and this side is congruent to itself. So we have 2 sets of congruent triangles, or we have 2 congruent triangles there. And what that's going to mean is that you're going to have this angle is congruent to this angle. Okay? So that's something that we can take note of. Now, with that in mind, let's go down here and look at these theorems. If a quadrilateral is a kite, then its diagonals are perpendicular. Okay? So if we drew diagonals down here, one of the things we would find out is that they're perpendicular. Okay? Now, if a quadrilateral is a kite, then it has exactly 1 pair of opposite angles congruent. And that's what I showed before. So we have exactly 1 pair of opposite angles congruent. Now, in exactly 1 pair, okay? No more, no less. And notice that in this case, it would be this angle and this angle. Because notice, if I draw the line across here, I've got a 2 congruent triangles. See, with angle, angle, angle. I mean side, side, side. Side, side, side. And it wouldn't work if we went the other way. In other words, if I said, well, here's what I'm going to do. I'm going to look at this. I'm going to draw my line this way. No, then we don't have congruent triangles, of course. I mean, you can just eyeball that and see you don't have congruent triangles.